Chapter 6 is factoring polynomial expressions. So what we did last chapter is we removed brackets. We expanded everything out. And we do a lot of inverse operations in mathematics. You started off in elementary, you would add something and then you would subtract. And you learned that there was a relationship between the adding and the subtracting. They're inverses of each other. We multiplied and we divided, inverses of each other. Last year we looked at squaring and square rooting as being inverses of each other. If I take 3 and I square it, I get 9. If I take the square root of 9, I get 3. So what we're looking at in this chapter is we're working backwards from expanding. We take something that has been expanded and we bring it back to its factored form. So when we do factoring, there's going to be some different methods that we're going to use this chapter. This is a key chapter for the Dash 1 courses. Actually, the next 5 chapters. If you are really looking at staying in Dash 1, these chapters are really important because the factoring is something that we take with us and we use it in grade 11 and in grade 12. The factoring we even do in Dash 2, so it's not like you completely have to forget it, but it is a very critical part to those courses. So we learn how to factor by removing a common factor, factoring a trinomial using inspection and decomposition, and factoring a difference of squares. So we can express a polynomial as a product of its factors, which we can then use to solve equations involving polynomials, which is what we look at next year. So last chapter, we expanded. We took something like 2x times x plus 5, and we removed the brackets. So we multiplied 2x by everything inside the brackets to get 2x squared plus 10x. When we multiplied binomials by binomials, we did the same process. We used the distributive property. We multiplied x by both terms in the other factor. And then we took the 1 and we multiplied it by both terms in the other factor. So the new terminology that you'll hear me use a lot in this chapter is we refer to these as factors. X plus 1 and x plus 3 are factors. Within those factors, x and 1 are terms within the factor. When I simplify this and collect my like terms, I get x squared plus 4x plus 3. So what I want you to do is I want you to remove the brackets or expand, that's the terminology, the next two, the 2x plus 3 times x minus 4 and x minus 5 times x plus 5. 2x plus 3 times x plus 4, what would I get?
2x squared plus 11x plus 12.
Because you get the 8x and the 3x? Yeah. So 2x squared plus 11x plus 12. And what happens when I take the x minus 5 times the x plus 5?
X squared minus 25.
Because again, when I go to expand this, I get a positive 5x and a negative 5x, which cancel each other out. So these are the types of polynomials that we are going to revert back to their factored form. We're going to take polynomials like 2x squared plus 10x, and we're going to write them as 2x times x plus 5. We are going to take something like x squared minus 25 and write it as x plus 5 times x minus 5. So there's patterning techniques. So when I go from left to right, we call it expanding. I've removed the brackets, I've expanded the expression out. When I move from right to left, we call it factoring. So just like if I went 4 times 5 equals 20, we would do multiplication. If I go 20 divided by 5, now we have division. They're inverse operations. Expanding and factoring are like inverse operations. Okay, so if we work backwards from above, we have 2x squared plus 10x. If we remove a common factor, and we take what we had above, when it was rewritten as 2x times x plus 5. That 2x became the common factor. Both, I can divide 10 and 2 by 2. X squared and x can both be divided by x. That's my common factor. Factoring a trinomial. We will eventually get to the point where when we see x squared plus 4x plus 3, we will be able to write it as x plus 3 times x plus 1. And we call that method factoring by inspection, because we'll be able to look at it and see that this should be a 3 and a 1 based on some patterning that we'll get into. 2x squared plus 11x plus 12, we will get to the point where we can write this as 2x plus 3 and x plus 4. There are two ways that we will look at for factoring these types of trinomials. We're going to look at it by factoring by decomposition, and the other one I call, it's kind of like inspection, but I call it by sight. And they work for certain types of trinomials. The biggest difference between these two trinomials is this one has a number in front of the x squared. It has a coefficient other than 1. So when I have a coefficient of 1, I get to use inspection. When I don't, I have to use decomposition or a sight. And then factoring a difference of squares, we will be able to go from x squared minus 25 to x plus 5 and x minus 5. And it doesn't matter if I write it as x plus 5 times x minus 5 or x minus 5 times x plus 5. The order in which these two factors are written doesn't matter. So this one here, I could write it as x plus 4 and 2x plus 3. It's the same as saying 5 times 3 is the same as 3 times 5. So the factors don't matter, but the way that the terms are arranged inside the factor does. So it does matter that I have this written as x plus 3 and not 3 plus x. So at the beginning of the semester, we looked at greatest common factors. The greatest common factor of 48 and 72 we found through prime factorization, or with enough practice, you start to get to know what your greatest common factors are. The numbers that we deal with when we're factoring our polynomials are small enough that we probably don't need to do prime factorization most of the time. The GCF, if I am doing prime factorization, what I do is I take 48 and I write it as a product of its prime numbers, 2s and 3s and 5s, etc. So I get 2 times 2 times 2 times 2 times 3 for 48, and 2, 2, 2, 3, and 3 for 72. So my common factor is the factors they have in common. They both have a 2, they have another 2, they have another 2, and then they have a 3. So I get 2 times 2 times 2 times 3, which becomes 2, 4, 8, 24. It becomes my common factor. If I have monomials such as 6a cubed and 9a squared b, I can use the same process. I look at the 6 and the 9. What's the greatest common factor number for a 6 and a 9? The biggest number I can divide them both by. 3, which is what was common with their prime factorizations. Then I look at the letters. A cubed is a times a squared, a times a, and b. So when I look at what they have in common for letters, they have an a, and they have another a, which would give me an a squared. So if I have 8x squared y squared and 20xy cubed, if we write 8x squared y squared as a product of prime numbers, If I divide 8 by 2, what do I get? 4. If I divide 4 by 2, I get 4 divided by 2? 2. And if I divide 2 by 2? 1. So I keep working down until I get to 1, dividing by 2's and 3's and 5's. The x's, so x squared would be x and x, and y squared would be y and y. When you're dealing with x's, how many of you have ever noticed that my multiplying x looks different from my variable x?
Your X is in kind of curve.
Yeah, it's kind of done in cursive, and even in the book, x is always done in italics, and it's done on purpose so I don't confuse it with a multiplication sign. The other way that you might see it written so that you don't confuse it with a multiplication sign is to use a dot. Or I can use brackets. So just make sure you're not confusing your x's and your multiplication symbols. 20xy cubed. So what is the biggest prime number I can divide 20 by? 5. What's 20 divided by 5? 4. What prime number can I divide 4 by?
2.
2. So 4 divided by 2 is?
2.
And 2 divided by 2 is? 1. So now I can stop. Then I have an x, and then y cubed is y multiplied by itself 3 times. So now if I look at what my common factors are, they both have a 2, they both have another 2, they both have an x, and they both have 2 y's. So if I put that all together, 2 times 2 is,
4.
and then I have an x, and y times y, y squared. I do not expect you to have to do this much work when you're determining your common factors. If you want to write them out as prime factorization, you can. But if you can look at 8 and 20 and realize that 4 is the biggest number, then just go to 4. And then when I'm dealing with my variables, if they have the same variable, the x is going to appear there. How do I know whether or not it's an x or an x squared?
It's a smaller number.
It's always going to be the smaller exponent. So this is a y cubed and a y squared. I pick the y squared because I don't have 3 y's to take out. I only have the 2. So class example number 2. If I look at 12ab and 15a squared b's cubed, what is the greatest common factor? So what is the largest number I can divide 12 and 15 by? 3. And then what letters? What would be my variables?
A, B.
And b. And there would be no, it would be a to the power of 1 because I can't pull 2 a's out of this one. I can't take an a squared out of that one. Okay, so look at b. 18 and negative 24. What is the largest number I can divide 18 and 24 by? 6. And what would my variables be? X cubed,
Y squared.
y squared. Okay, so I want you to do C and D on your own. So what's my greatest common factor for a cubed bc squared and 2ac to the power of 7? So what number do they have in common? Do they have a 2 in common or a 1 in common? A 1. Do I need to put the 1 there?
No.
Nope. Okay, what about the letters?
A, B squared. A, B, A, C squared. A, C.
AC what?
Squared.
Squared. Can I take a b out of both terms? No. So because I can't take a b out of both terms, it can't be a common factor. And the most c's that I can take out is a c squared. So the smallest exponent is the most that you can take out. Even though there's 7 in this one, I can only take 2 out of here. So I have to be able to take the same amount out of each term. If I look at D, what is my largest number that I can divide negative 40, negative 20, and negative 10 by? Negative 10, because they're all negatives. So if they're all negatives, I'm going to take out a negative. If you took out a positive, it's okay for now.
Good.
What would my letters be?
A squared. B.
And B, because there is a B here. Good. Okay. This is how we factor polynomials with removing the greatest common factor. Instead of having 12ab, comma, we put in a plus. And then we factor this out of each term. So that's on the next page. So factoring a polynomial, or factoring is a process in which a sum or difference of terms is expressed as a product of factors. So a polynomial like 8x squared y squared plus 20xy cubed, those were the two terms that were in the previous examples, can be factored by a process that we call removing or taking out or dividing. So when I'm going through these, I will sometimes use the word let's factor out or let's take out. Taking out is the same as factoring, and they're all meaning dividing. So we divide out the greatest common factor from each term. So from before, we knew that the greatest common factor of 8x squared y squared and 20xy cubed was 4xy squared. So when we factor that out or take it out, we're actually dividing each term by this 4xy squared. So 8 divided by 4 leaves me with 2. X squared divided by x leaves me with x. The y squared and the y squared cancel each other out. They equal 1. So that leaves me with 2x when I take out or divide by the 4xy squared. If I take 20 and divide it by 4, I get 5. X divided by x cancels out. It equals 1. And y cubed divided by y squared leaves me with 5y. So when I go left to right, if I go this way to expand, I get my original expression. If I take that original expression and factor it, I get the two factors. So if we look at class example number 3, I have 21x and 14y. Look at the two numbers. 21 and 14. What is the largest number I can divide them both by? 7. They do not have a letter in common, which means I cannot divide by a 7x or a 7y. So I can only divide each term by 7. 21x divided by 7 leaves me with my 3x. 14y divided by 7 leaves me with 2y. So if I look at B, I have 5x to the power of 4, 15x to the power of 3, and 5x squared. So if I start off with the numbers, what is the largest number I can divide these three by? 5. And then look at the variables. What is the largest variable I can divide x to the power of 4, x to the power of 3, and x squared by? X squared. Because I can take 2 out of here, which means I can also take 2 out of this one and take 2 out of this one. So then when I do the division or the taking out, 5 divided by 5 is 1. X to the power of 4 divided by x squared leaves me with x squared. 15 divided by 5 leaves me with 3. X cubed divided by x squared leaves me with x. And 5x squared divided by 5x squared leaves me with 1. And I have to put the 1 in there. It's important. It doesn't just disappear. So in class example number 4, we're given what the common factor is. The common factor has been removed. We just need to finish the process. So in 5a squared plus 25a, the common factor was 5a. So if I divide each term by 5a, 5a squared divided by 5a leaves me with a. And 25a divided by 5a would leave me with what? 5. What would happen to the a's?
Cancel each other.
They cancel each other out because it equals 1. Okay? So if I look at b, in this case they factored out a 2. So that means dividing each term by 2. What's 18p divided by 2? 9p. And then 16q divided by 2 would be 8q. In C, we factored out a negative 2m. So it means dividing each term by negative 2m. So negative 4 divided by negative 2? 2n. And then negative 6m squared divided by negative 2m. 3m. If I look at D, the factor that has been removed is 9x. So it's dividing each term by 9x. So 18x squared y squared divided by 9x would equal 2xy squared. A negative 45xy divided by 9x. Negative 5y. And 9x divided by 9x. Plus 1. And that plus 1 has to go in there. That's the most common error that students make, is when it equals 1, they don't put the 1 in there. This is a plus 1. It's not timesing by 1. If it was multiplying by 1, I wouldn't need the 1 there, but because I'm adding by 1, I need to put that placeholder in there. So in class example number 5, we're just asked to factor. So we have to combine what was done in class example 3 and 4 and do everything on our own. So we start off, look at the numbers. What is the biggest number I can divide 20 and 6 by? 2. Can I divide both terms by a variable? No. So if I remove a 2, what would I be left with? Yes. Okay, so if I look at B. 4 what? 4x squared becomes my greatest common factor. So if I factor that out, what would I be left with? 4x squared plus 1. Okay, I'm going to give you some time. I want you to do the next 3 on your own. Same process. Okay, question C. What is my greatest common factor? 2ab squared. And what would that leave me with?
5a squared d plus 4.
No, there'd be no b now because the b squareds would cancel out.
That's 4b plus b squared.
Good. Okay, what's my greatest common factor for D?
3p.
3p. So what would that leave me with?
4p squared minus 2p plus 5.
What is my greatest common factor for E?
5xy squared z squared.
So this one becomes a little bit more confusing just because of all of the different variables in it. But the thing to remember is the smallest exponent is the only one that you can have. So the smallest exponent on x was a 1. The smallest exponent on y is a 2. The smallest exponent on z was a 2. So if I take out or I remove this 5xy squared z squared, what would I be left with?
5.
5z
minus 4xy squared plus 6x cubed z cubed.
Good. Okay, we have one more question.
Yay.
Yay! Have one more question in another lesson. Okay. The surface area of a cone is given by the formula A equals pi r squared plus pi rs. R is the radius of the cone and S is the slant height. Determine the surface area of a cone to the nearest hundredth of a square centimeter, which has a slant height of 7.4 centimeters and a radius of 2.60 centimeters. So my surface area formula would be A equals pi 2.6 squared plus pi times 2.6 times 7.4. So tell me what that would equal. So what'd you get?
Numbers.
What numbers?
Numbers. Down.
What's the first number? 8 and a 1 decimal.
6, 8, 1, 4.
So to the nearest hundredth would be
6, 8.
6, 8. And what are my units?
Centimeters squared.
Okay. So now we're asked to write this in factored form. So if I look at my pi r squared plus pi rs, what is my common factor? What can I remove from each term? Pi
R,
and an r. So if I remove a pi and an r from the first term, what am I left with?
R,
And from the second term?
Yes.
So I get pi r times r plus s. So we are going to use this formula to calculate the surface area. I guess I should put SA. So surface area equals pi times r, which was 2.6, times 2.6 plus 7.4.
It works.
What do you get?
Same.
I would hope you get the same answer because it's the same cone. Which formula did you like better?
More complicated.
It's a personal choice whether you like the first method or the second method. But if you look at the second method, when I was going through it,
It's less complex.
if you can add these two numbers together using mental math strategies, which I was able to do, and I get 10, which I now can multiply by 2.6, I can now type into the calculator 26 pi, which is even less than what I have to do here.